Welcome to Math 65. Today we are going to do some factoring. So this is the last section on factoring, and it's basically a summary of everything we've learned about factoring so far. So this is just titled Factoring Strategies. General factoring strategies. What's the number one rule of factoring, you guys? Oh, look, you knew it. If there's a GCF other than 1, factor it out, right? Because the reason why we even use this word prime, not that it necessarily applies to specifically this, but like the word prime in general just means that there are factors of only 1 and itself. That's the definition of prime. So it doesn't do us any favors to factor out 1. It's not going to change the value at all. It's going to be exactly the same. So if there's a greatest common factor other than 1, why do we do that, by the way? Why do we factor out the GCF? Yeah, to make it simpler so that whatever is left is going to be more easily factored, okay? Then we have these special cases. So we're gonna know that if we're gonna look and see if it's a binomial. Now, who can remember what does it mean for it to be a binomial? 2 terms. 2 terms. Okay, a binomial has 2 terms. And so we have these special cases. In fact, what section, does anybody remember what section let's actually mark the sections. What section did we learn about? If you wanted to go back and review GCF, what section would you go to? Do you know? 7.1. 7.1, we learned just about factoring GCF. These special cases, what is this first special case called? It has a special name. Does anybody remember? Oh, close. Dots. It's dots. Why is it dots? Difference of 2 squares. This is most famous, most popular. I would say if I had a preference, it is my favorite one, right? Would anybody agree it's your favorite one because you love perfect squares? Yeah? And let's remember, what are perfect squares? What are perfect squares? This stands for difference of 2 squares. We learned it in section 7-4. No, 7-5, sorry. In the old book, it was -4. Okay, 7-5 was a special case. What are perfect squares again? Yeah, a number multiplied by itself. So if we look at the times tables, they form this diagonal down the center, 144, because it's 12 times 12, or 12 squared, right? And then we have these other ones. I don't really give them a special name, but I guess you could call them cots. Cubes. No, not difference. No, difference. It's still difference. This is the square. So this would be difference of 2 cubes. Don't get that confused with dots. Okay. Or sum of 2 cubes. And they just follow that formula. So I was just looking at our CCOGs for this class, and I realized we don't have to memorize, I don't think, these 2 formulas. We'll have to discuss that. I don't think we do. So I'm going to give you these formulas for your test. Just the difference of 2 cubes and sum of 2 cubes. Now, if it's a trinomial, and what is a trinomial again? Has 3 terms. Well, I'm just going over if it was cubes, they could follow these formulas. And that's what we learned last class. Trinomial, there's a trinomial, we can do one of the following. Factor by finding the correct factor pair. So that's what we learned in 7-3, if the leading coefficient is 1, using the AC method, and that was in 7-4. Maybe I should put it over here, 7-3, 7-4. And actually, I would even add something to this list. Is there anything that you can think of? Are there any kind of special trinomials that we learned about? PSTs. I would add to the trinomial list, is it a PST? And you can look for that in section 7-5. PST stands for perfect square trinomial. Okay? And then Step D, if there are 4 terms, remember factor by grouping, and then check your answer by multiplying. What was the special acronym that you used to multiply 2 binomials once they're factored? FOIL. FOIL to check. FOIL to check. That basically means the same thing because we use FOIL to multiply binomials, don't we? Okay, so for these, we're just going to always want to factor completely. So I would even suggest we first look to see, is there a GCF? That's always going to be our first step. I don't see a GCF here. Do you guys see one? Okay, I just gave it away though, right? So, and then we're looking for, what are we going to do to factor this now? We're looking for 2 numbers that multiply to 9, so we're going to factor 9, and they have to have a sum of 10. Now look at the signs. Both positive. So what would you start with here? 1 times 9? Oh, that adds to 10. What would you start in the first position then? Plus 1, x plus 9. Is that what you're going to say next? Okay, this seems too easy, right? You guys know how to do this already. So let's look through the packet and see if there's any that you want me to do. And if not, I'm going to have you do them so that you can get points for coming to the board. Look and see if you can find one that you think, oh, that one looks really hard. I want her to do that one. Can you see from example 2 or example 3? Has a cube. Okay, well, let's just start. Let's go to this one. I think you guys can do the other ones pretty easily, but let's just go to 2B. We're on the second page. And number 1 rule of factoring, always, always look for a GCF. Is there a GCF here? Okay, and y. So the question just came up, should we factor out a -4? Yeah, because another rule we didn't actually go over is but I've said it in the past, if it starts with a negative, factor out the negative. So we are seeing here that the GCF is -4, anything else? Y. -4y. And if you divide both terms by -4y, what will you get? Y squared minus 9. Okay. Now remember, we always want to factor completely. That means that if we factor out a GCF, we can look at what's left and decide, is it factorable or not? Why would you say it's factorable? Oh, what does it look like? It looks to you like, are you seeing it? So he's saying, what are you saying about the 9? It's a perfect square. What are you saying about the y squared? It's also a perfect square. Anything to the second power is a perfect square, right? So -4y, the GCF just comes down and it's along for the ride. What do we call this special case right here? We were just talking about it. It looks like the difference of 2 squares. That's going to be your most famous, most popular binomial that can be factored. Y plus minus, what goes next? 3. Why are the signs exact opposites of each other? Right, so that you can have a negative here, but also what happens to your middle term, your outside, inside? Yes, because you get positive 3y, negative 3y. That will give you how many y's? If you had positive 3y minus 3y, how many y's would you have? 0 y's, which is the same thing as 0, right? 0 times y is 0. Okay, another one. This is any choice. You get any pick of any problem that you want me to do right now. Yes, Eli? On the same one? Oh, sure. I like how you say that with a smile on your face. Can you do A? Um, so what are we going to do? We're going to try and factor 5. Now 5 is a prime number, so all I got is 1 times 5, or negative 5 times negative 1. If I add that together, that's 6. Negative 6. It doesn't work. Now you cannot tell me it's prime unless you know that you've checked every single possible combination of factors. Okay, that's the only way you can determine. Lucky for me, 5 is prime, so I don't have that many factors to choose from, right? The reason why my list is so short. So now we can safely say this is prime. But just because you didn't find the factors that work doesn't mean necessarily that something's prime. You know what I mean? You got to keep dividing. Which one? 3B. Let's go on to the next page. We're going to do 3B. Oh yeah, that one looks interesting. Okay, 3B right here. Number 1 rule of factoring, the first thing I always want to start with is GCF. Who can see? Is there a GCF here? What would you say, Elizabeth, that it is? I like negative t squared. Why is she deciding to factor out the negative t squared? Yes, because there's a negative at the beginning. So let's make our job a lot easier. We have never factored something that has a negative in the beginning. You know why? We factored out the negative. So we never have to do that. We never have to have it be negative. Just factor it out. At the beginning is what I mean. Okay, so if you divide everything by negative t squared, what are you going to get? Oh, why minus? Oh, every sign is changing. I was going to put plus as well. I was going to, okay? Minus what? 3t, okay? We're dividing this, and if you want to make a little note to yourself, even though it's not mathematically equal here, you could just, I don't care if you do this little negative t squared, just to remind yourself you're dividing by negative. Okay, what will you get as the last term? Okay, now we want to see, can I come up with a factor pair that multiplies to negative 2, but has a sum of negative 3? Is it possible? What would it be? But negative 1 times negative 2 wouldn't give me the negative 2. You see how the signs have to be opposite of each other? I was going there too, but now this would add to 1. I can't really think of anything else, so it's not factorable. I mean, nothing else is factorable, right? We can't break it into 2 binomials, because if I have positive 1 and negative 2, that's going to add to a negative 1. The only way I'm going to get that negative sign there is if I have 2 opposite signs, and that's not going to give me the 3 that I need. Does everybody understand why I can't factor any further? So the inside right here is prime. So we just are going through this list, and we're really just deciding. Let's do another factor by grouping just to remind ourselves of what we do when we have 4 terms. So factor by grouping, I'm going to group the first 2. I'm going to group the last 2. What do we do once we've grouped those first 2? We're going to factor out the what? GCF? Yes. So what's the GCF here? X squared. And what gets left behind? X plus 2. And then what about the GCF of the last 2? Negative 9. Negative 9, and that's because, oops, and I wrote a 4. I don't know why I did that. Because it starts with negatives. Starts with a negative. Okay, and what's your factor pair? What's your binomial? X plus 2. Questions on that so far? Remembering this? This is coming back. I think we learned factor by grouping in like 7-2. I forgot to write that on the front page. Okay, what about now? X squared minus 9. Okay, anything else? Oh, can we keep going? What do we get now? Is either one of those factorable? Which one? X squared minus 9. So x plus 2, we can't factor. There's no GCF. There's no squares. How would you factor? What is this called? And how does it factor? Dots. Difference of two squares. And tell me the factors. Why don't you tell me, Michael? X plus 3. Okay, and that comes up a lot. I can't even tell you how many times in Math 95 you're going to see difference of two squares. I just can't even tell you. Countless times. Okay, any others before we move on? Let's have you guys try the rest of them. Okay, you have your protocol there, and we'll have some volunteers come and share out.